Multiplication of polynomials. Multiplying monomials requires the use of exponent rules. So let's look here at multiplying x squared times x to the fifth. We're multiplying numbers of the same base, so we add the exponents. Xy squared times 4xy, so 1 times 4 is 4. X and x, I have two x's multiplying each other, and a y squared and a y means I have three y's multiplying each other. Negative 3xy squared times 4x squared y. I have negative 3 times 4 is negative 12. X times x squared is x cubed, and y squared times y is y cubed. Recall the distributive properties. For any real numbers a, b, and c, a times b plus c is ab plus ac, and a times b minus c is ab minus ac, where we're distributing that number just outside the parentheses to everything inside the parentheses. Now that we'll be distributing variables through a polynomial, we'll need to apply our exponent rules. Multiply and simplify the expression. Here I'm distributing from the right side. Nevertheless, I'm still distributing. So z times 4 is 4z, minus z times z is z squared. Now I have 3x times 5x squared minus 4. I'm still distributing. I have a 15x cubed for my first term, and my second term would be minus 12x. Here I have a negative 8 multiplying everything inside there, so I'll have a negative 32t squared minus 8t minus 8. When we multiply polynomials of more than one term, we need to make sure each term in the first polynomial multiplies each term in the second polynomial. Some people like to use the acronym FOIL when multiplying two binomials to be sure that they're multiplying all the required parts. So here we're multiplying x plus 2 times x plus 5. We want to make sure that x multiplies everything in that second parenthesis, and that 2 multiplies everything in that second set of parentheses. So I'm multiplying the first terms, I'm multiplying the outside terms, I'm multiplying those inside terms, and multiplying the last term. And that way I get the FOIL acronym. When I do that, I have x squared plus 5x plus 2x plus 10, and I simplify by combining those like terms, and that gives me a 7x. We could also demonstrate the multiplication of these two binomials geometrically. Here I have a square that is lengths x and x. Here I have an extra 5 added on and an extra 2. So this length is x plus 5. This length is x plus 2. When I multiply x times x, I get x squared. Finding the area of this rectangle, it will be 5 times x, 5x. Finding the area of this rectangle, it would be 2 times this length x, so 2x. And this last rectangle, a length of 2 times a length of 5 is 10. Now you can see these red squares are like terms. I can go ahead and add those. So my polynomial is x squared plus 7x plus 10. Multiply and simplify the expression. We're going to use FOIL here, so you may want to give yourself enough room to draw those arrows for the first few that we do. X times x is x squared. so we did the first terms. Now we'll multiply the outside terms. X times negative 9 is negative 9x. Negative 8 times x is negative 8x. That was the inside. And my last terms, negative 8 times negative 9 is positive 72. Now I have like terms in the middle that I can put together. That would give me x squared minus 17x plus 72. 8b minus 1 times 8b plus 1. A FOIL problem. Again, a binomial times a binomial. So 8b times 8b is 64b squared. 8b times 1 is positive 8b. And negative 1 times 8b is negative 8b. And negative 1 times 1 is negative 1. Now combining my like terms, the middle terms completely cancel each other out. So I'm left with 64b squared minus 1. 10y plus 7 times y minus 1. Let's set this up for FOIL again. So I have 10y times y is 10y squared. And I have a 10y times negative 1 is negative 10y. 7 times y is 7y. 7 times negative 1 is negative 7. Combining like terms gives me 10y squared minus 3y minus 7. X squared plus 4 times 4x minus 3. Let's set this up to FOIL as well. So I have x squared times 4x is 4x cubed. X squared times negative 3 is negative 3x squared. 4 times 4x is positive 16x. And 4 times negative 3 is negative 12. Now I don't have any like terms to combine here, and all my exponents are in descending order, so I'm finished with this product. Here I have the binomial m plus 1 times a trinomial m squared plus 3m plus 1. Now we can't use FOIL on this because we have more than 4 terms when we finish multiplying, but we'll use the same principle. The first term in the first parenthesis multiplies each term in the second parenthesis, and the second term in the first parenthesis also multiplies every term in the second set of parentheses. So let's go ahead and try this. M times m squared is m cubed. M times 3m is 3m squared. M times 1 is m. Now we move to this second term of the binomial. 1 times m squared is m squared. 1 times 3m is 3m. 1 times 1 is 1. Now I have some like terms I can put together. I have a 3m squared and an m squared there. So let's start off with my m cubed. 3m squared plus m squared is 4m squared. And then I have an m and a 3m. That gives me a positive 4m plus my constant of 1. Now everything has been combined that can be combined, and all of my variables are in descending order. That covers this section. Go ahead and try your homework and let me know if you have questions.